My name's John Moorman. I'm an IT architect at One Call Care here in town. And at One Call Care, we work within the workers' comp industry. So when someone is hurt on the job, we work between the insurance company and the injured worker to get them the care that they need, to get them back on their feet as quickly as they can. So today's session is going to be, well, I guess first I should say, thanks for coming out at 8:30 in the morning on the last day of Code on the Beach. Good to see a good turnout here, and hope you've all had a great time. It's been great to see everyone in person after the last couple of years, so glad you're all here. And today we'll be talking about event-driven architecture, and in particular, the events that are associated with various Azure storage types. So from the event-driven architecture side, we're going to talk about it more at like a conceptual level, and then we'll be drilling into the different types of Azure storage, ways we can respond to those events, and we'll have code samples of each of them. So to start my own PSA, if you can give blood, please do. Most of us can give blood, but not a lot of us do. I've been a regular donor for over 30 years because I'm A negative, plus I have a type of blood that they can use on infants. So actually at the beginning of the pandemic, for the first time that I've been donated, I actually had the hospital calling me, telling me they had 3 babies in NICU that needed my blood, and it's crazy. They opened up a section of the hospital just so I could come in to donate. So it's weird. You do affect people's lives. So if you can, please do. And we've got 2 good ones here in town, Life South and One Blood. Multi-gallon donors on both of them. So like I said, my own little PSA there. So today we're going to be, like I said, we're going to be talking about event-driven architecture, some of the concepts behind it, some of the pitfalls, and some of the benefits that we get from it. Then we'll be looking into the different types of Azure storage and the events and how we respond to them. So to start with, event-driven architecture, I found this up on Wikipedia, and it's really accurate and really pretty boring. So from a less formal perspective, event-driven architectures, something changes in your system. You send out a notification, and systems that want to know about that can respond to it. So the tsunami evacuation zone, I thought, was a perfect emblem of this. So a seismic event happens in the ocean floor. Seismologists, geologists detect it, and they're able to say, this might affect the people in this area. So they send out a notification. People in the affected areas have the choice. They can respond to it or not. So some of our benefits, one of the things we are doing with event-driven architecture is we're looking at creating more domain-specific domain-specific services. So I'm not sure that I really like the term microservice, since we define what microservice is. We have some monolithic applications, but they serve as a single service. Meanwhile, we have some newer ones that are more in the micro space. So a lot of it depends upon where you are in the journey and how you get there. One of the great things about it is a lot of it is driven by APIs. So we can have everyone from junior devs that can come in and they can begin helping out by building some of this. We also get the benefit that we decouple our systems from each other. Where this becomes really important is deployments. I worked at a company, and I know they still deploy this way. They spend the weekend deploying. So 40, 48 hours of deployment. And inevitably, every Sunday morning, there's a message that comes out saying, this thing failed. Because they have everything all jam-packed together. By decoupling and planning for that with like circuit breaker patterns and things like that, we can actually bring the systems, we can allow the systems to deploy at will, moving towards a more continuous deployment type. And the last, one of the last benefits of this is the event brokers for the event-driven architecture are pretty well defined. Whether you're using Azure Service Bus, whether you're using Kafka, MessageMQ, RabbitMQ, all of these are well defined. You find a lot of good coded samples out there, and there's, well, really just a lot of documentation on it. Some of the problems with event-driven architecture is that you're talking about more distributed systems. And sometimes, and while it's really good because you can learn very deeply about your topic, sometimes it's hard to see the big picture. And so we need the architects involved so that they can help the junior developers on it, and the senior developers too. So it actually does, you do need a good cross-section of people on your teams, and that provides the benefits. And so it's a complex design. Testing is still a work in progress. There's still some issues like how do you emulate an event? You can, but it's something that a lot of us aren't familiar with doing. Security is also a work in progress. So Melissa, we do need to get security involved. And so I have met with Dimitri, we've talked some things through. So security, do you need to encrypt your messages that when you broadcast them out? How do you go about this? And a lot of it is what appetite are you willing, what appetite for risk are you willing to take? So we're going to be talking about a bunch of different items today. So Azure Service Bus, Cosmos, Azure Storage, Cognitive Search, and sorry, the last couple we're not going to get to. We'll also be looking at Azure Logic Apps, Function Apps, Data Factory. So what happened is a few years ago, I'd actually come to OneCall to help build a database for their new flagship product. And about a year and a half, 2 years later, I was pretty comfortable with the Azure SQL and was trying to figure out what next. So I saw all these other Azure storage types, and I'm like, what's a good way to use them? How can I use them? How can I react to them? So what I did is as Cecil said in the intro on Monday, he's like, find something that's a good example or something that means something to you. So it's like you can make something meaningful. So some of you may know I have a large collection of bootleg albums, live recordings from different bands. Back in the 90s and the 2000s, I would trade other collectors. And so I had all of my albums stored in a Excel spreadsheet so I could send it out easily. So I said, what if I take these bootleg albums, I create a quick console app which will read from that Excel spreadsheet and write to the Azure Service Bus. Then I can create a Azure Logic app which can subscribe to the Service Bus and write that document into Cosmos database. Well, Cosmos database has this pretty cool feature called the change feed. And I was able to use a Azure function to monitor the change feed and then write the change documents down into Azure Blob Storage. Then I created a web crawler in my Azure Data Factory which looked for changes and then wrote it up into Cognitive Search. Now, just for the record, this is not a pattern to follow. The sole purpose of this was to touch as many different things as in many different ways as I could. And this is not anything that I would ever propose. So, to start with, Azure Events, and you do need to be familiar or at least comfortable with some of the way that Azure breaks things down. So in Azure, we have our subscriptions tied to our SDLC. So we have a dev subscription, we have a QA subscription, we have a UAT for business testing subscription, and we have a production subscription. So you do need to know that if you write if you send a message in your dev subscription, production knows nothing about it. So it is contained to within the subscription. It is low latency. And if you start getting so many events firing that your latency starts getting, Microsoft will allow you to pay them to get it to go quicker. And then the other thing about events is they can be either time-based. You can have some kind of polling event that takes place every 2 hours, or when a specific event occurs. Say a message hits a topic. So to start with, let's look at the console app. And the console app is used, it's not very exciting, but it's used to pull the data from Excel and write it to the Azure Service Bus. So diving into it, here's the main meat of it after it's read off. I did actually zoom in a little bit so you can see this, and this is all working code, by the way. So here's where we're going to be creating our message. We pull the data from it, and then here at the end is where we're actually writing to the topic. Nothing terribly exciting, but it shows you. It's like some of these things, some of these concepts are pretty basic in nature. So what exactly is Azure Service Bus, and why would we want to use it? And Azure Service Bus is a message broker. It's an event broker for us. It's broken up into, we typically use a pub sub subscription. So we're going to publish a message, and then systems that are interested in that message can subscribe to it. Also within these messages, we can set them up as either a topic or as a queue. And the difference is a topic can have multiple subscribers. So at one call, say a new patient comes in. When we send an event for that, there's other systems that might want to be aware of it. We might need to kick off our business rule engine to see, is this an insurance company that we can actually bill? Is it a workers' comp claim? There's other things. We might send an email or a text to an adjuster that we know at that insurance company to let them know about this. We might also send something over to our scheduling department saying, hey, we're going to have this person coming in soon. They're going to need some services. So all of that is within the topic. Now a queue is when you're going to get things a little more specified. You know exactly who your source is, and that source goes to a specific target. So an example of this might be in the accounts receivable or accounts payable area, or you may not want to be publishing your rates. And so you want just to go from one place to the other place, and you don't want anyone else subscribing to it. And why would you use that? It's like, you know, why would we want the queue? And again, for decoupling the systems, by using the queue and by using the topics too, we can write the message to the Azure Service Bus, and we're done. You know, everything's good. If the receiving system is offline, say it went down, or they're updating, once it comes back online, it'll have all those messages in both the queues and the topics waiting for it to process. So this decoupling is pretty important. Guaranteed order of operation, first in, first out. So you're never going to get an update before you get an insert. Highly concurrent. So again, we're talking about the latency here. And Service Bus is, one, it's asynchronous, it's redundant. You can even make it geo-redundant if you want. There is a great tool called Service Bus Explorer. It's available up on GitHub. But do be aware that Service Bus Explorer requires elevated privileges. So you need full access, including reading and changing messages. So you might get it, assuming you're developers, you might get it in dev and QA. You're not going to get it in production. And if you're production support, yeah, then you might have it in production, but that would be about it. But I must say, there is also Azure Portal Service Bus Explorer. And a year ago, I would have said, bleh. But like everything else Azure, it's evolved over time. It's actually looking pretty good right now. And you can see where they pulled a lot of things from Service Bus Explorer into it. No real surprise, since the people that wrote Service Bus Explorer were Microsoft employees, or are Microsoft employees. So looking at it, we could see here is our Azure Service Bus. Here is our list of subscriptions, and we have 2. And we can dive into these subscriptions and actually look at the messages within Service Bus. So we could click on the message, and we can actually see the full message down here. Service Bus does have it in what I think is a little bit friendlier fashion. So here we could see the main window in Azure Service Bus Explorer. On the top here, we have our queues. And then here we have our topics and the subscriptions. So the way we use Service Bus Explorer is every service has its own topic. And every service is responsible for writing messages to that topic. But then anyone else can subscribe to that topic. Another key concept here is time to live. So if your message goes out here onto the service bus and it's not read in X amount of time, it's like, okay, what's going on here? And after X number of days, in this case it's set up as 14 days, it'll actually go into the dead letter queue. And so we regularly monitor that. We monitor the dead letter queue and move it over to another system to figure out, hey, why'd this dead letter on us? And just like in the portal, we have a messages button, and now we can come over here. And like I said, we could click here, get the details below. And like I said, a couple of more custom properties, which give us a little more information about what the message is. So again, wouldn't surprise me, in the portal if we get that in the near future. So Azure Logic Apps. These are simple. These are ways. It's a low code, no code environment, but it allows us to set up ways to orchestrate and schedule, and what else did I use? Schedule, automate, and orchestrate different business processes. If you're used to PowerFlow, if you're working in the Power Apps, I can't find any difference between PowerFlow and the Azure Logic App. To me, they look very similar. And there's hundreds of different connectors, probably thousands of different connectors. One of the first Azure Logic apps I ever wrote back pre-pandemic, I had a Bing Map API. I'd ping it with my home address and my work address and find the quickest way to work. I then connected it to my Office 365 account and sent myself an email. So between 7 and 9 a.m., I knew the quickest route to get to work, and between 5 and 7 p.m., I knew the quickest way to get home from work. So there's lots of different things you can do with this. Logic apps have been talked about as being a BizTalk replacement. And while they are really good for bringing those different systems all together, one of the problems with them is BizTalk orchestrations are powerful. They're the strength of BizTalk. And it has all the mappings. There is no way to translate the mappings from BizTalk into Azure Logic App. So you're gonna have to redo them one at a time. And it was like, ugh. So BizTalk is still good through 2027, so we have a couple more years. Again, coding knowledge is useful but not required. Another fault of, I call it a fault, of Azure Logic Apps is there's no CI/CD pipeline. Not quite sure why this is, because behind the scenes it's all JSON. But there may be some now. When I was refreshing for the conference, I saw some references out there. However, the references weren't very good for for the workings of the CI/CD pipelines. So I was actually hoping for that seminar this afternoon, which sadly was canceled, to wonder if that had changed. But to the best of my knowledge right now, there still are no CI/CD pipelines for Logic apps. And where are we using an Azure Logic app? Right here. So we're going to be reading from the Azure Service Bus and writing over to the Cosmos database. Here is the entirety of the workflow. Very, very simple and easy to read, easy to understand. So you can see here from the first one, what we're doing is we're defining our source. Down here on the bottom is we have our Azure Service Bus connection string. Here's our topic and our subscription. Done. The second part of it, there is a slight difference between a message and a JSON document. So we have to convert it. Really, it's just a simple cast. And then the last part is connecting to our Azure Cosmos database. So again, the same thing here. We have our connection. We're going to be writing to the music database in the bootleg collection. We're going to be passing the content, which is the document we received, and specifying a partition key value. Now, partition keys are pretty important in Cosmos. You use the partition key to distribute your data throughout your Cosmos database. So it's real important to choose the correct key for your partitioning. By choosing the correct partition key, you're able to read and write with incredible speed. We could probably spend maybe not a full session, probably a good half session talking about partition keys. We actually had one that was defined poorly. It was written in years. It was only the year, because we said, oh, we're never going to get more than the 2 million or whatever it is keys within the partition. Well, that was good until November. And then one of the other architects are like, oh, and of course the person who wrote it was on vacation. So we dove in there, and it's like, okay, well, for now, let's just change it over to year, month, day. And we were able to do that and get the database back up again. The last comment there is upsert. It's actually an important thing to know, more on the Cosmos side. So at first I was like, why doesn't it just say is merged? Don't we use merge everywhere else? But the way Cosmos actually processes an update is by deleting the old record and creating a new one. So there's no update in place for Cosmos. Which brings us a little more towards Cosmos. And Cosmos is wonderful. I'm saying that a lot, but I'm excited about data. I'm a data guy. Microsoft has been throwing a lot of money at Cosmos in the last couple of years, and it really shows. So it's the Microsoft NoSQL data store. We could do either document, key value, column family. We could even set it up as a graph database. And Jeff and I were talking about that last night. So graph database is when you go from edge to edge. So like in Facebook, you're friends with someone, they're friends with someone, and you're able to do that kind of thing using some of the graph database concepts. Again, being a data guy, every field is indexed. Not like your Azure SQL database or your SQL servers or your Oracles. Every field is indexed. In fact, you have to tell Cosmos not to index a field, because by default it indexes everything. There's also 5 different consistency models. This is a new one for some of us more relational guys, but we have everything from strong consistency, which is your typical RDBMS ACID, to eventual consistency. So if you ever saw something on Amazon, you're like, oh man, this price is too good to be true. And so, well, I'm going to try to get it. And you try, and it comes back saying, yeah, you got it, John. And it's like, hey. Then an hour later, you get that email that says, nope, sorry. We reconciled, and someone else got it. And so, I'm never that someone else. I'm always the recipient of those emails. So by default, it's in the middle of the session. So any changes you make during your session will be available to you. The latency 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 guarantees. 99% of all reads in less than 10 milliseconds. It's not a typo. This is the SLA. 99% of writes, less than 15 milliseconds. This does, actually, as someone asked at SQL Saturday, it does require you to specify the partition key in this. So that's how they get it, so they know about where it is, and then they get that information back fast. It's multi-tenant, global distribution, so you can have all different systems into your Cosmos database. Cosmos is actually, Azure Portal is built on Cosmos database. So Microsoft, true to form, is eating their own dog food there. So they are using this. You could also set it up to be geofenced. So say no one outside the US is allowed to see your data. You can actually configure geofencing within Cosmos. Multi-homed, this is another one. Say everyone in the class is trying to access one document, and I go to access that document. It might say, well, it's pretty busy over here. Let me give you the one from US West. So it automatically figures out where the closest place that has that data is and gets that back to you. Change feed, we talked about that briefly. So the change feed actually identifies documents that have changed. And it sends it all off, and you can, well, more or less subscribe to it. You can actually watch it. One thing I did want to specify, you do need to design your documents carefully. And this goes pretty much with everything JSON-based, because over time, if your documents change too much, say you have a field moved to a different level, guess what? You're either going to be searching for that, you're only going to be searching the new documents that have it at the level you're expecting it, or you need to tell it to search at 2 levels, or you need to go back and change all the documents in your history. None of them are an easy task, and it's not perfect, but eventually, well, eventually you do what you got to do, but the whole thing, understanding the data format in the present tense, will help you in the long term. Now again, here is actual Cosmos database. Zoom in on that a bit. And if you remember from our Logic app, here is our music database, bootleg collection, and then all the items in that connection. Up here at the top is the query that it sets up for you to begin with. And it is it is ANSI SQL compliant. It is not Transact SQL. It is not PL SQL. It's actually its own flavor of SQL. And so there are some things you could do with it, which is just like any query language, you'll learn the nuances. One thing to be aware of, it doesn't join quickly. So if you're searching for documents, very fast. If you search for a document, join to a second document and maybe a third document, not so much. You might face some challenges there. And we can dive into it and looking at a specific key. Here's our ID. And then here at the bottom is our keys that are set up by Cosmos database. So the row identifier, the self and the E tag. The big one here is the timestamp. And thanks, Alejandro. You showed me recently how to convert that timestamp to a date time. So this timestamp, and for Microsoft people, is more similar to the Oracle or the MySQL timestamp, where it is actually a date time value. And it is not the row version available within SQL Server. So just something to be aware of. From here, we're going to jump over to Azure Functions. Function apps, snippets of code meant for quick, repetitive actions. You don't want to build your entire application within a function app. That's not what it's designed for. They're meant for the repetitive executions, multiple executions. We use it a lot to read from the bus and into a calling app. You can deploy directly up into your your Azure subscription, but we've actually been deploying to Kubernetes, which allows us to have a little bit more flexibility in increasing the latency and being able to scale up and scale down more rapidly. We can include libraries, so you've got the full power of .NET within your Azure Logic apps, or Azure Function apps. Sorry, getting all tongue-tied this morning. So you also have your full integrated security, your identity manager. We can include that in there. And probably should really remove this punchline, but you can code in Azure Portal, and you probably will the first time you go do it, but you'll quickly realize that doing that in Visual Studio is a much better way. And also too, by coding in Visual Studio, you can take advantage of CI/CD pipelines. And again, looking over here to this, spreadsheet. Where are we doing this? We're looking at the Azure Function reading from the change feed and writing it into blob storage. And here is, the next eye test. But this is just about the entirety of all the logic inside our function app. One of the things that's really nice about this is the declarative nature. So we could simply tell it what connection string we were looking at, database name, collection name, and then our change feed, the things that we wanted to look at. Likewise, on the blob side, we have our connection string. We're saying we're going to be writing to the blob, and that's it. And we're set up. So the first couple times, it's a little bit of what, but quickly it becomes very easy because of the declarative nature to configure this into your code. And then here is the entire code logic. And we just starting with the for each, saying, hey, every document that we find in the change feed, let's extract the properties. And then we're going to be writing that down to our blob container. We have a couple little, string manipulation functions. But again, nothing. We don't want to have a lot of logic within our logic. We don't want to have a lot of logic within our function app. Azure storage. And believe it or not, this is one of the topics I like the best. And you think of Azure storage, it's like it's your hard drive in the cloud, right? It's like, yeah, but it's so much more. So the blobs are HIPAA compliant. Really big, we're in healthcare, so we want to make sure everything is HIPAA compliant. And it's durable, secure, encrypted by default for quite a few years now, scalable, managed, and as with everything Azure, there's multiple copies of it. There is a tool out there from Microsoft called Azure Storage Explorer. Don't use it. I highly recommend against it. And maybe it's just because we have a lot of different storage containers out there, but it probably takes 15, 20 minutes to load up. And then if you want to find a document somewhere in there, see you tomorrow. So yeah, Azure Storage Explorer, not that good. But we also have, we can configure disks up there. And the disk can even be configured to work for multiple VMs. You can even connect an on-prem VM to an Azure disk. So there's some pretty cool things with the disk storage. File shares. You could set up a file share just up in Azure Blob, and you could share things out there. Queue storage. Again, this is just a place where you might want to put messages, and when you write to it, when you read, whatever you wrote first, you get that back first. And speaking to my Microsoft rep, Azure Service Bus is actually written on queue storage. They've added some special magic, I'm sure, but really it does the same thing. Everything that you would expect from queue storage is what we find within the Azure Service Bus. There's also tables. So you think of it as key value pairs or column families. It might be a good place if you didn't want to keep if you had common lookup data throughout your enterprise, this might be a good place to write it. And you can keep it out there. It's a low-cost solution to having that data in one common location. And the access tier. Now, here's where you get into the money and the performance part. So the hot storage, you're guaranteed sub-second response time to get to your data at a cost of about 2 cents per gigabyte per month. Not very expensive, and there's even things you can do to get down from there. Then you have your cool storage, which is half the price. It's only a penny per gigabyte per month. And you get your data within a second. So it's like, oh, that's not bad. Then you have archive storage. Microsoft SLA on archive storage is 6 hours. I'm like, what? As a rep, you're kidding me, right? He's like, oh, don't worry. He's like, you typically get it within the hour. I'm like, all right. I go, why? Well, it turns out archive storage is actually stored on magnetic tape. I'm like, you're kidding me. I have never been to Azure Storage Center, storage facility, but I know some people who have. The Azure data centers. You're white suited. You come in there, you check your ID 2 or 3 different times. They have armed guards at the door. And you go in and it's like cue the 2001 Space Odyssey music. And you come in, you hear the air conditioning lights. The lights are low. Mostly you get the lights from that. And then all this cool new high-tech stuff. And over in a corner, there's your good old mag tape from the 1950s and 1960s. Now, I'm sure they've added some cool robotics and stuff to it, but really that, from what Microsoft told me, they're like, it is a very inexpensive storage mechanism with long-term durability. And it costs 1/100th of 1 cent per gigabyte per month. So if you have requirements, client requirements that say you need to keep this data forever, see how quickly you can get it there. Now, there are some things you don't want to do it if you're going to be pulling it out of archive storage a lot. Microsoft, I saw the terms that it seemed pretty generous. I can't remember exactly how many, but I know it was in the thousands of access per month. And then if you exceed that, they're going to charge you a little bit more. Like 1/100th of a cent per gig per month. Okay, I think I'm good with that. And if it's stuff that you're not going to do, really good idea. So here's how you see Azure Storage up in the portal. Tried zooming in. There was nothing I could do to make it look good. So here, I eventually went just and typed it all out. So a bunch of it is basic configuration. Do you require HTTPS? Why wouldn't you? Would you allow anonymous access? Well, you know what? Maybe for our marketing materials or public assets, maybe for our marketing assets, definitely not for our patient records. So we can also configure the default storage type. Another thing that's good to know is your replication. So how your data, most of the time your data is right there, and that's your local redundant storage. But if you need the geo-redundant storage, set it up actually to the third option here. So it's actually read access geo-redundant storage. So the second option is just a GRS. When you put it there, you can't read it on your geo-replicated backup. But with the read access GRS, you can actually read the data. I think the GRS says if it fails or if your service goes down on US East, it will automatically update to read access, but just set it up there. So this way, if you have people out on the West Coast, that they get a closer version of the data. Here's how your blob storage or your storage configured. You see the different types of data. You get a good little summary. And then we can actually dive in it. We can see here the different blob containers that we have. and we could see all the folders within that blob container. I even went through and changed a couple over to different types of storage types or access type, just to give you a sample to look at. But you can see here, hot, archive, and then cool storage. Azure Data Factory. Again, being a data guy, I love Azure Data Factory. And you use Azure Data Factory to push data from point A to point B. That's it. It's like SSIS in the cloud. It doesn't, by default, have some of those advanced transforms that we get within SSIS. But we've been using ADF for about 4 years now. We have not need to pay the additional to get those more advanced transformations. Completely JSON-based. So a lot of times what we do is we actually put the metadata into a table. It's probably way advanced, but we pull that data out so that in the future, all we need to do, say we need to add a new field or field name changes, we could simply update our metadata and we don't have to redeploy the entire pipeline. So because it's all JSON-based. There are a couple challenges inside the CI/CD pipeline. We managed to get around most of them using some regex. We also found that reaching out to Microsoft can be beneficial. We called our Microsoft rep right after ADF version 2 came out, and we're like, why can't you have expose this? And we actually spoke to the product manager over at Microsoft. He's like, oh, no, yeah, hey, that's a good idea. Yeah, let me get my team to work on that. I'll get that into our backlog. And all of a sudden, a couple days later, we just looked by chance, and sure enough, it was there. It was like, oh, wow. A couple days later, our Microsoft rep called up, and she's like, hey, I'm about to talk to the product manager again. Is there anything else you want me to add? Just like, hey, thank him. The change is already there. This is great. So yeah, so Microsoft, again, they have the continuous deployment too, and I guess they felt that this was important enough to get out quick. So don't be afraid to ask. And so again, we're using Data Factor here on the bottom to look for changes in our blob storage, and we're going to write that up into our cognitive search index. So here's actually, within our data factor, here we're defining our data set. We have our connection string called here link service, and we have a couple parameters that are going to be passed in from the trigger. And I'll show that in a couple slides from now. So that was our source. Here's our destination. We're going to be copying up into a cognitive search index and to a specific index. And then we define our Azure Data Factory. It's one component plus a trigger. So it's just our copy data. And so again here, we have our parameters. So we're looking at our source folder and source file, which we're going to get from our trigger. Then we set up our source. And again, this is going to be our blob storage. So we're just saying, hey, where's our data set? Here's the values that we're looking at. And that's really it. We're going to set up our sink, and that's Microsoft use, I guess, a new term for destination. I guess destination, they wanted to get it to a smaller form. So we're going up into our cognitive search, merge, and then we specify our mapping. So we have all the values in our source, and if the names are different in our destination, we set that all up here. And that's it. That sets up our ADF pipeline. And then we just need to set up the trigger. And the trigger, this is just going to be a blob storage trigger. When something changes in a particular folder, we want to be aware of it. So we could set up some different filtering options based upon the file name and the type of activity. Was a blob created? Was it updated? What do we want to do about 0-byte blobs? And then we just set up what the information that's going to pass. So again, we get here the folder name and the file name of what changed, and we're going to be populating that into our parameter. And that's the full pipeline for moving the data, for pushing that data up into Azure Cognitive Search. And if you haven't used Azure Cognitive Search, it's Microsoft's take on Elasticsearch. People get all bent out of shape about the nuances. They're not all that different. And like everything else, or almost everything else up in Azure, this is JSON-based. Has full support for Lucene queries, so that's important. We do have the REST API, and with regex, HIPAA compliant, again, healthcare. Synonyms and relevance scoring, you can say John with an H is equivalent to John without an H. And even relevance scoring on that. Autocomplete, so you can build this to give you your Bing or Google experience where you get the autocreate as you start typing, autocomplete when you start typing. It does have a blob crawler, so technically I didn't really have to do the Azure Data Factory, but like I said, I'm a data guy. And actually, I don't think it was available. I'll say it wasn't available when I first wrote it. There is a geospatial search on it. Be aware it is point to point, and which kind of makes sense, but in case you're hoping to find the shortest driving distance in cognitive search, I haven't seen anything that does that yet, but it does do point to point for you. And you could say, hey, what's the item nearest to One Ocean? And it'll give you that as the seagull flies. And here is our cognitive search index. So we can see here, 2,000 documents, no shaming about my obsession. Comes down to only 1.8 megabytes of space. So it is very equivalent, or very performant, compresses really nice. We actually, early on, we actually loaded up one of our larger record sets with 26 million patients in it. And we blew it up into a cognitive search index, and then we started searching and searching and searching. We tried to get every kind of complex case you can imagine, and we couldn't get that search result to return in more than 1 second. Everything came back sub-second. So some of the performance on the search queries are incredible. You can see why Elasticsearch is so popular and why cognitive search is so popular. You do need to define how you're going to use the fields, whether they're retrievable, whether they're searchable, whether you can use them in a filter clause. So there's a couple different options for you here with that, and you can configure it up here. We actually configure it using Postman, so we then can take that Postman script and put it up into GitHub, into our Gits, and so we can keep the history of it. And within the portal, you do have a UI. You can see how it translates it and then pulls out your data. Much simpler way is to just, and maybe it's just because I got used to using it, but I like the way Postman does it. It's very simple to configure, and you get the same results. This is the exact same query as before, except we added a count to it. And you can also have much more complex queries. So if we're looking for Aerosmith and a show near Japan, we can actually do that. Oh, and you can see here, 132 milliseconds. Granted, there's only 2,000 in there, but still pretty impressive. And then I guess here is showing that it really is finding us one from Japan. One thing to be aware of, we just found this out, we knew it, but we found out that the code didn't handle it well, is you're not guaranteed. It's not, when you search a SQL database, you find an exact match. We were actually looking for a provider with a particular phone number, and we knew that that phone number existed within our system. So we did the search, and our UI kept saying, can't find anyone, can't find anyone. So, like, what's going on here? Well, for some reason, the cognitive search, the search score was put this exact match on the phone number into the second position in the returned result set. So you don't always get an exact match. It was like 0.677 to 0.665 or whatever it was. It was close, but you do need to code for the fact that you may not get your exact one. If you're familiar with the search, the SQL Server search, full text search. Full text search in SQL Server works the same way. It doesn't guarantee you can execute the same query and get two different answers. And that's also true up in cognitive search. And I'm amazed. 51 minutes. So I actually pulled all the screenshots into this because I used to go swap between applications, but it always ran into 80 minutes. So I do have some other slides up here if you're curious. I know someone was asking the other day about stretch databases, so I do have a little bit of information up here about stretch databases and managed instance. Also, Synapse Analytics, parallel data warehouse in the cloud, data lake analytics, and Databricks. If you haven't used Databricks, Databricks are, if you're familiar with Hadoop, Hadoop has lots of spinning disks throughout your network. And you might query Hadoop, and it might take you a day to get the answer back, but it's okay. Say you need it back quicker, you can load it up into Databricks, and instead of the spinning disk, it loads all your data into memory. And as you might imagine, it's a pretty expensive operation. So the first time I ever configured Databricks to play with it, it was the first time I'd ever seen something from Microsoft say, hey, if you don't use this for 2 hours, we're going to shut it down for you. Even still, I burned through my $100 budget in one weekend's work. So be aware, there are some other options up there. And I actually have time for questions if anyone has any.
Is Cosmos, what's the pricing of Cosmos?
The pricing for Cosmos, it is more expensive than like an Azure SQL database, but it all depends upon the feature, but it is a more expensive solution.
On the cognitive search, does Microsoft have an offering much like how Elastic has a dashboard offering like Kibana and also expresses some charting?
Okay, so does Azure Search have the charting
Module or something?
So Azure Search does have the ability, you can build a dashboard directly on top of it. You could also set the number of replicas. So if you need even more speed, yes, it does have that configuration option.
And suppose the same type of complex query search like Elastic does in terms of keyword search and all the and, or, and should not, and all of those?
Yes, so, well, I think I can answer that, and that'll also include the question. So, Elasticsearch, I believe, was the original developer of the Lucene query, and the full set of it is currently supported within Cognitive Search. Anything else? If you think of something later, I'll be around all day, and otherwise feel free to reach out to me. Thank you very much for attending.